Okay, so we're talking about graphing. You already know how to graph sine, and it looks something like that. Now, what about the sister to sine? Cosecant. That's the thing I'm trying to teach you how to graph today, is the sister function. If that's sine, cosecant is 1 over sine. I don't know if you've got that yet, but that's how they're related. They're flip of each other. Okay? So if you know what sine looks like, which is this red one, then cosecant, whenever sine is 0, do you get that cosecant will have a problem? Because you're 1 divided by 0. You can't have a 0 right here. So wherever sine is 0, cosecant is going to freak out. So sine is 0 here, and here, and here. So that means an asymptote line here, asymptote line here, an asymptote line there. And then the last part is you just have to make loops like this. If I'll tell you why. Do you agree that at this spot right here, sine is equal to 1? And then you'll have 1 divided by 1. 1 divided by 1 is 1, so it matches up right there. And then as this gets smaller and smaller, this will get bigger and bigger. All right, so final answer, that is 1 period of cosecant. Judging by what I just showed you there. And by the way, I should take the red out. There. Now that's the graph of cosecant. It rides on the back of sine, but all right. Now I'd like you to graph cosine and do the same thing and try to figure out what the graph of secant would look like. Start by graphing cosine. 4 marks. Give it your best shot. Be back in a second from a pause. Okay, so we are resumed again. Okay, I didn't mean to press that. I want to go to this. Okay, and I asked you to graph cosine. Do you remember that cosine starts up at 1 and then goes down into the valley, emerges from the valley, and ends up back up again? It's basically a big U shape. Okay, that's cosine. So then, if secant is the twin of cosine, the evil twin, then secant is really equal to, I should just put an equal sign there. Secant is equal to 1 over cosine, and therefore, wherever cosine is 0, secant will freak out. Same deal as last time. That's the spot where it's 0. That's the spot where it's 0. How many of you knew to put to put dotted lines there? Asymptote lines there. Good. Then, how do you finish this? You make 1 loop here. How many had that part right? Okay, and then how do you do the end? Right. Like this and like that. Did anybody have it perfect? Awesome. Okay. It's lunchtime. All right, we're back from lunch, and when we last left, we had just graphed secant. It rides on the back of the sister function cosine, and you got to know where cosine is in the first place, but when you're all done, you really want to just take that out. That's gone, poof. Now that's the graph of secant. Now, a common mistake, I find it's kind of helpful to tell you what the common mistakes are so you don't make them. Common mistake is for a kid to just complete this and it bothers them to only be halfway done, and so they go like this. And the problem is then you have graphed more than 1 period of it. So on the test, don't do that. Now you got 2 ups and 1 down. That's not even complete. It's not even 2 whole cycles. But we're going to want you to graph 1 period of it. So don't include those little extra wings there. That's it. It's done. All right. So to the 2-second review, sine was like this. Whoop, and so cosine, the one that rides on top of sine is cosecant. Wherever sine is 0, has asymptotes, and then it goes like this and like that. Raise your hand if you get that. Okay, good. Then the other one just rides on the top of cosine. So here's cosine. Cosine starts out at 1, makes a big valley, and then you go wherever it touches and makes 0, it has to be undefined. So you have these, and now we just make it right on the top like this, and that, and that. Okay, so there's the 2-second review of how to graph the sister functions. Yes. If you wanted 2 periods of it, then you would want to continue this all the way out here, continue this all the way out here, and I'd need a whole nother down loop too. Okay, so to get that, I'd have to just continue my graph further. Did you guys all come back way earlier than you had to, or what's the deal with that? That's weird. All right, so I'm going to continue this out, and let's say like that, and then I'd have to go like this and like that. And you'd have an asymptote line wherever cosine is 0, so you need another asymptote line running through here and running down there. Okay, so anyway, now that's 2 full periods of it. You get that? And just keeping the pattern going. All right, now what are your jobs today? Well, the first part of the worksheet asks you about between negative 2 pi and 2 pi. So that means you have to make 2 whole periods of it. So I'm going to give you a quick sketch of cosecant, because here's sine. Sine goes like this, and I'm going to continue it out like that. Cosecant rides on top. This, and this, and that. And then I need dotted lines here because those are the spots that sine is 0, and that's making cosecant crash at those spots. All right, so the green one is the graph from negative 2 pi to 2 pi. And then they'll ask you things like, what's the y-intercept? Good question, isn't it? There is no y-intercept because it's an asymptote, so there is no y-intercept. Then they're going to ask you things like, what are the x-intercepts? Well, the x-intercepts are, wait a minute, it never touches the x-axis. There are no x-intercepts. Then they might ask you for something like, when is it equal to 1? Well, when is cosecant equal to 1? It's equal to 1 right here, and here, here, here. And what are those spots? Well, this one, for instance, is 3 pi over 2. And hopefully you know all of these spots. This one's pi over 2. This one would be, I think I'm off a little bit. That's supposed to be moved over a smidge. But anyway, that's going to be negative pi over... Maybe it's not. Anyway. Okay. Let me think what it really is. Yeah, that is at negative pi over 2. And okay, anyway, there's your basics of what you have to do. Now here's the advanced what you have to do. What if they ask you to graph 3 cosecant of, oh, I'll even make it a little harder, 2 theta, or 2x. I guess we usually use x in that scenario. All right, so my first thought would be graph the parent of it. All right, go like this. Cosecant rides on top of sine, so you graph sine. Sine goes like this. Number it, 2 pi, pi, pi over 2, and 3 pi over 2. Are you following me so far? Okay, now how do I do cosecant? I do the loops on top, this, and like that. Asymptotes on all sides. Okay, next thing. How do I make it 3 times as tall? I don't have to move it. That spot used to be 1. I'm just going to fake it and change it to a 3. And this spot used to be a negative 1. And I'm just going to fake it and change it to a negative 3. There we go. Took care of that part. Boop. Next part is that 2. That 2 affects the period because get how it's going to squish it. Seems like it should be stretched, but then that's counterintuitive. So it's actually squished. It's going to get squished down. So you say the period equals 2 pi over b. You're going to use this a ton. So what's b? 2. So I put in a 2 there. And 2 pi over 2 means the new period is now pi. So that means this 2 pi right here has to be changed. And I get rid of the 2 pi and I put in a new one. And I say now it's going to be pi though. So what did I really do to that? I divided it by 2 or multiplied it by 1/2. So I do that to everything. And I'd have things like pi over 4, pi over 2, and 3 pi over 4, I think. There we go. So there's my new numbering. Once I've got it newly numbered, yeah, I don't even have to move the graph. Let's leave it alone. All right. There's only one other possible thing they could do to you, and that is a phase shift. Let's say that I wanted to move this whole thing over. If I just put a subtract pi here, that changes everything. If I go minus pi, now my phase shift is C over B, which would be pi over 2. I got that? That over that. So I'm supposed to shift this puppy pi over 2. But now, pay attention. How far is pi over 2? It's not this far anymore. We renumbered. Pi over 2 now lives here. See that? So I'd have to shift it that far. So the whole graph needs to be shifted. And it says minus, so I go to the right. So I'm going to make my new one in like some weird kind of fuchsia color or something. Make it a dotted one like this. And here's my original was like this and this. And now I'm going to have to move them. How far? I have to move them this far. Pi over 2. So I'm going to grab this, move it over pi over 2, which is 2 notches now. There we go. And this one goes over 2 notches. Whew. That is the hardest possible thing you can see. That's like the hard R3. Because you had to do 3 things to it. Usually you only have to do 2 things to it. Okay. So you have some time, and here's a worksheet that helps you practice these skills. The graphing test is coming. We only have 2 class days left between now and when you take the test. We have 2 more days. 1 more day to talk about tangent. I'll teach you that tomorrow. Or wait, no, tomorrow's the weird day where we're losing a day due to the Heart Week festivities and whatever. The next day I'll teach you tangent. That's Thursday. I'll teach you tangent, cotangent. And then Friday, most of you won't be here. And then Monday you won't be here for sure because there's no school. And then Tuesday review. And then Wednesday we have the test. Okay, so that's where we're at. Could you take 5 off the top here?